I'm going to go ahead and get started. Thank you and welcome to today's November California-Nevada Drought Early Warning System Drought and Climate Outlook webinar. Thank you for those that have joined us previously and those that are joining us for the first time. My name is Amanda Sheffield. I am the Regional Drought Information Coordinator for NIDIS for California and Nevada. This bi-monthly webinar series is designed to provide the region with timely information on current drought status and associated impacts, as well as a preview of developing climatic events. This webinar is co-hosted with the California Nevada Applications Program, a NOAA RESA team. Just to note, this webinar is being recorded, and the recording along with a 2-page summary flyer will be available on drought.gov later this week or early next week. We have a great webinar set up for you guys today. Before we get started, I'll just briefly remind those who haven't heard about NIDIS before what we are. Our mission is to improve the nation's capacity to proactively manage drought-related risks, including those affected, by providing those affected with the best available information and resources to assess the potential for drought impacts. We work to improve our understanding of how and why droughts affect society, the economy, and the environment, and make that information accessible and usable for early warning information. Our approach to achieving this goal is building the foundation of a national drought early warning system through the development of regional drought early warning systems, where the networks of partners and stakeholders share information and actions that help communities cope with drought. As I mentioned, we have regional systems as we work towards a national drought early warning system, with California and Nevada being one of them. And activities such as this webinar contribute to the activities that make up the system as a whole, where we utilize new and existing partner networks to make readily available and easily understandable and usable information for decision makers around drought. And so these include activities around observation and monitoring, prediction and forecasting, interdisciplinary research and applications, planning and preparedness, communication and outreach. And you can find more information on drought.gov or contact me after the webinar. I'll also just briefly mention a big thank you to those that recently attended last week's California-Nevada DEWS partner meeting. We were in Sacramento with a whole bunch of different partners talking about current drought activities, new research and resources, emerging issues, and identified collaborative paths forward with the California-Nevada DEWS. More information will be coming soon to the drought.gov event, including the presentations and things like that from the meeting. So I want to mention that in case those who weren't able to attend are interested in the information or want to reach out to me to learn more about the California-Nevada DEWS. With that, I'll go ahead and get started and explain who our speakers are for today. So today, as many saw when you signed up for the webinar, is our toolkit webinar. The idea is we'll have Dan McAvoy from the Western Regional Climate Center give the drought and climate update, followed by Julie Clancy from Scripps and CNAP giving the outlook. And they will also be sharing tools that will be useful to listeners like you all as you go out through the winter to track conditions and forecasts and information that you may need throughout the winter season as we start to get our rain, snow, etc. So with that, I will go ahead and kick us off and pass this over to Dan McAvoy. As I mentioned, he's a regional climatologist with the Western Regional Climate Center at the Desert Research Institute in Reno, Nevada. And I'll mention that if you have questions, feel free to type them into the questions box. We'll try to get to maybe a quick one after each presenter, but otherwise we'll save most of the questions for the end. Dan, are you ready to present?
Yes, I am. Thanks. Let's see here. All right, you got my screen?
Not quite yet. We still see the white box.
Let's see.
Oh, wait. There it goes. Now you're good.
Okay. Awesome. Well, yeah, I'll get started. Thanks for the introduction, Amanda. So what I'm going to do today is give you all an overview of kind of the current water year to date and the drought and climate and weather conditions that have led to that. I know there's a very kind of interesting and exciting and probably mostly beneficial weather week ahead that Julie's going to cover most of that, but I'm going to talk about kind of how we got to where we're at right now. And this photo on my cover slide is from Mount Rose ski area that I took from November 11th, and it's kind of a funny picture. They were open for skiing early November. There were a few nights of cold temperatures that allowed them to make some snow, but you can see the natural landscape under the lift. There was no snow at all. And up near the top of the lift, you can see some of that man-made snow. Now, this is about 8,000 feet on the northeast side of the Lake Tahoe Basin. Early November, it's not that uncommon. We have years without snow, but this just shows there was no snow at all and how dry it was, and I'll discuss some of that. Let's see here. So I want to start out with the big picture in the U.S. Drought Monitor. On the left, we have the most recent U.S. Drought Monitor map from that was released on the 21st with data through November 19th. And then on the right, we have the changes in the Drought Monitor over the past month from October 22nd to November 19th. So currently in California, Nevada, there is, I would say, at least 2/3 of the two states, if not more, are covered in some shading there. Most of that is D0, which is just abnormally dry. And then once you get into parts of Southeast California and Southern Nevada, there is some moderate drought conditions that are still on this map, and even some D2 severe drought, some pockets in Southeast Nevada. Now, this was only through November 19th. It didn't account for the storm that we had early last week or middle of last week that I'll talk about. And so there's likely to be a lot of changes in this map in the next couple renditions of this map. And I would imagine, as you'll see from some of the recent rains and some of the forecasted rains, that a lot of this D0 at least will probably be removed in the next few weeks. And the other thing I want to point out was most of these changes were made in the last month due to the very dry start to the water year, which it shows in the change map there. Most of the D0 was introduced last week or within the last 2 weeks. So how dry has it been for the beginning of this water year? This map shows the precipitation percentiles or rankings for the start of the water year, October 1st through November 22nd. And this is from the Northwest Climate Toolbox. And this uses data that goes from 1979 to 2015 rankings. And so any of these dark brown shadings along coastal California and the Sierra Nevada, Northeast Nevada, are showing the driest start based on that 1979 to 2015 period. So very dry conditions. As you go further south, again, this was due to a recent storm that I'll talk about. The percentiles aren't so bad, and there are some above normal conditions now in the southern part of the region. So yeah, we did have a storm last week that brought some good rain and snow, but that was mostly to the southern part of the state in California and Nevada, and also the eastern Sierra, but it didn't really hit the west slopes or central or western Nevada at all. And so the previous map had rankings from 1979, but if we look at some of the more long-term station data, we could see how dry it has actually been to start this water year. Of course, we do have, it's not that uncommon to have a dry October, but then as we get further towards the end of November, it gets much more uncommon to have these very low precipitation totals, particularly in the Sierra Nevada and in places closer to the coast. So the top left is Tahoe City, which has data that starts in 1906, and this was the third driest start to the water year. This was through November 24th. Bottom left is for Blue Canyon. This is on the west slope of Sierra Nevada. This is one of the wettest places in the Sierra Nevada due to the proximity and where it sits on the western slope. This is data that goes back to 1940, and this was also the third driest. And then San Francisco, downtown, the station has data going all the way back to 1850, which is a great station to look at long-term climate. And this is the fifth driest start to the water year in that record. And so this just shows how dry it actually has been. And what's interesting also to point out is that I'm showing the top 10 rankings here. And especially in the Sierra, even going from this year, which is is the third for both the Blue Canyon and Tahoe City, when you get down to the 10th, there's a huge jump, just indicating that we don't have these extreme dry periods very often. For example, for Tahoe City, the 10th driest is over an inch of precipitation, and this year is at 0.03, so basically no precipitation. So extremely dry start to the water year. But we did have a storm. This is from the California-Nevada River Forecast Center, showing the 7-day total precipitation from November 16th to the 23rd. Most of this event happened early to mid last week. So there was some very high totals, especially in Southern California and the Southeast deserts in Southern Nevada, 1 to 3 inches or more in some places. But I want to point out the big hole in Central and Northern California into Northeast Northern Nevada, where no precipitation at all fell. So this was an interesting storm. It was a cutoff low that favored Southern California, and then the wraparound moisture hit the Central Great Basin and the east slopes of the Sierra Nevada. And this was a pretty good soaker for parts of Southern California that have been very dry leading up to that. The map on the bottom left is from Climate Engine, and it shows the total precipitation from the 18th through the 21st of November. It's showing in Southern California, east of San Diego, in the mountains, some places upwards of 5 to 6 inches of rain. I took a look at some of the observations. The biggest one I was able to find was for Mount Laguna, which is about 5,700 feet. And over a 2-day period, they got over 4 inches of rain there. So that was a very big event for them. Then on the bottom right, this is the water year accumulation graph for McCarran Airport in Las Vegas. And up until this storm, they had 0 precipitation for the water year. For the storm alone, they got about 0.7 inches, and the brown line there is showing the average for the water year. So they went from 0 to above average for the water year with 1 storm event. So this was beneficial for the southern parts of the region. But again, let's just emphasize how dry it's been, especially in the Sierra Nevada. I want to show you these indices from California Department of Water Resources that combine a bunch of different weather stations for the northern, central, and southern Sierra Nevada. This first one is the Northern Sierra H Station Index. The teal shading is the average for the water year from left to right, October 1 through September 30th. The average is about 51 inches for this region. I've highlighted in the red box where we're at right now. You can hardly see it. There's a dark blue line there, 0.03 or 0.3 inches so far for the water year, 4% of normal. But normally around this year, we're somewhere around 6 or 7 inches. Again, so almost no precipitation for the west slopes of the Sierra Nevada. Now we move down into the Central Sierra, into the San Joaquin Basin. It's a 5-station index. Their index is at 0, so no precipitation at all. This was through November 23rd, extremely dry. And you go further south into the Tulare Basin. They're at 0.3 inches as well, which is 8%. So again, we had the beneficial rains in the south, but nothing on the west slopes of the Sierra Nevada or other parts of Central California. So part of the reason that we do have this D0 currently over much of the state, over much of the region, one of the impacts is fire danger. We did have some pretty severe fires earlier in the fall. So a large part of this was due to the antecedent dryness and the lack of onset of the fall rains in the region. And so what I'm showing here is the 1 and the 2 month evaporative demand drought index, or the EDDI, and this is a measure of the atmospheric thirst. And we've seen over the past 3 years with large fire outbreaks that for each and every one of those large fires, that leading up to those fires, the EDDI has indicated very high evaporative demand. And so what this is telling you is that in those dark reds, the 2 top darkest colors of red, that's well above normal evaporative demand. And so that's a combination of above normal temperatures, high winds, low humidity, and few clouds, so high pressure, less storminess. And so we see that there's still very high EDDI values all over Northern California down through the Central Coast at both 1 and 2 month time scales. So this was ending November 19th on the left, considering the previous month, and on the right, considering the previous 2 months. So we still have this fire danger until we get the soaking rains that hopefully we'll get later this week. And then the other big impact is to the rangelands this time of year. I heard a great presentation last week at our stakeholder meeting from Leslie Roche from UC Davis, talking about the impacts of drought on rangelands and what they're doing to try to help provide input on those drought impacts. So these two maps on the left shows the dispersion of rangelands across the state of California, private and public, so a good portion of the state is covered in rangeland. I couldn't find a similar map for Nevada, but what I did find was a map of all the BLM grazing allotments. So each one of those polygons is a grazing allotment, and so both states have a large area of rangelands is the main point. And so the quick drought response index can give you a measure of the condition of the rangelands. It's a shorter term drought index or range index. It combines precipitation, vegetation health, soil moisture, the evaporative stress index, which accounts for actual evapotranspiration and evaporative demand. And so, and part of the reason I showed that map before was that not all the state is covered in rangeland, so these maps might not be applicable everywhere, but almost the entire region is in this much drier than normal 4-week period in terms of range conditions, very dry vegetation. The other part of the range conditions, and I'm probably going to botch this, and if there's anyone on the line who might want to comment later, feel free, but Leslie had mentioned that the onset of the fall rains are very beneficial to germination of the seeds for the next season of range grasses, and and then you also have thresholds due to cold temperatures when you get too late in the season, and so it's really beneficial to have the onset of the fall rains not too late in the year to improve the next crop of range grasses, which we've not got yet. So that was all kind of related to the short-term drought conditions and what those impacts are. Luckily for California and Nevada, we have a very good water management and reservoir and water supply system, and so we had a very good winter last year, a good snowpack and precipitation, and most of the reservoirs filled up to near or above normal over the summer. And so this is just a snapshot of the reservoir conditions. On the left, we have California's conditions, and then on the right, we have some of the major Nevada reservoirs, Lake Tahoe, Rye Patch Reservoir, which the Humboldt River Basin feeds into that, and then the Lahontan Reservoir, which comes out of is fed by the Eastern Sierra. And so all of these are showing near to above normal reservoir conditions. But we do want to be aware that, even if we have one drought year, some of these reservoirs can get low pretty quickly. Lahontan is one of those. You can see already it's about half full. So if we had a drought year, it could go down pretty quickly. Lake Tahoe is a bit different. It takes a couple of years of drought to really bring that reservoir down. But we want to be mindful. Yes, the reservoirs are in good shape, but they can go down quickly if we don't have some large storms come in early in the season. And this is just building on that. This is a graphic that Mike Dettinger provides that's hosted on the CNAP website that combines the reservoir conditions with the snowpack. And this was through November 20th. We don't really have any snowpack right now, which I'll show in a minute. So this is mostly reservoirs. And you can see the red line is showing a slow decline in the reservoir levels for the beginning of the water year, and that we can quickly get below normal without some big storms and snowpack to boost that all up. So we need to be mindful of that as we go through the year. And then finally on to snowpack. We don't really have much of snowpack at all right now. It's still pretty early in the year, but most places, above 7,000 feet or so in the Sierra Nevada, climatologically have started to accumulate snow by now. So we should have some snow cover on the ground, and a lot of these places have no snow at all. I thought it was really interesting. The map on the left is showing the percent of median from the SNOTEL stations based on 1981 to 2010. But the map on the right is showing the actual snow water equivalent from the SNODAS data set. And as I mentioned with that storm last week, it really impacted the eastern Sierra. And for example, that picture I showed from my title slide was at Mount Rose Ski Resort. They got about 6 or 8 inches of snow on the northeast side of Lake Tahoe. But you go into the western slopes of Sierra Nevada and they got nothing at all. And so, again, just this disparity between the west slope and the east slope is pretty big. And we did get a little bit of snow out into the Great Basin. But again, when you look at the dots on the SNOTEL map, they're all far below the median where they should be for this year. Now, this early in the year, that can change pretty quickly with 1 or 2 good-sized storms. We could probably get up back up to near or above normal snowpack fairly quickly. So just to summarize on the recent climate and drought, yes, it's not that unusual to be dry for some of the beginning of the water year, but we're having one of the driest starts on record, particularly for the western slopes of the Sierra Nevada and Central California. The southern parts of our region did benefit from the storm last week. That definitely eased the fire danger concerns, and the D0 and probably D1 in some of those regions will be changed or erased likely this week. And the drought impacts that we were seeing because of the late onset to the water year, again, is the elevated fire danger and the rangeland health. The reservoirs are in good shape, but that can change quickly, and we just need to be mindful that we really need some of those early season storms to stay on track with the reservoir conditions throughout the year. So that's what I had for the drought and climate update. And then I just wanted to highlight a few tools that hopefully you can all access and take a look at if you want to keep track yourself. This is weather, climate, and drought tools for the region. The first one I want to talk about is the Great Basin Weather and Climate Dashboard. This is hosted at the Western Regional Climate Center. And so this is a dashboard of a whole bunch of different resources. The first tab that is up there is the current conditions. So you can get things like the drought monitor, the PDSI, stream flow, reservoir conditions, and everything that's happening now. There's also a tab there that gives you a bunch of different forecasts and outlook tools. And then there's a third link that has just different links to planning resources. So the first thing you see on the current page is the latest drought monitor conditions and the PDSI from the West-Wide Drought Tracker, the VEGDRI, the Vegetative Drought Response Index, and the departure from greenness. But there's much more than this on the current page, and so this is just sort of some of what you can get from that current tab on the Great Basin Weather and Climate Dashboard. You get temperatures, departures from normal, precipitation, departures from normal, links to radar and satellite imagery. There are basin-wide SWE maps from the NRCS, stream flow and reservoir. We have the EDDI maps regionally and for CONUS. We have the Northern Sierra 8-station index, which I showed earlier. You can go right to that. So this is a quick stop if you want to quickly get to some of these links so you don't have to remember where all these are. It's a great resource to get started if you're trying to understand what the current and future conditions might be like. Another one I want to highlight, this is accessible through the Great Basin Climate Dashboard. This is the West-Wide Drought Tracker. This is also hosted at the Western Regional Climate Center. This has become quite a popular tool where you can download these maps and data. I've highlighted the California-Nevada region, but we have individual Western state maps for all the Western states. And then you can also get CONUS maps of these same features. So this tool is based on PRISM gridded data, 4-kilometer spatial resolution, and this tool uses the monthly data going back to 1895. The two variables are temperature and precipitation. And with those, we compute a suite of different drought indices. I'm showing some mapping examples, but we also have time series tools. And with any of these maps or time series, you can download the data and the maps or the graphs yourself, so you can use them in presentations or publications if you needed to. For drought indices, we have the Palmer and the self-calibrated Palmer Drought Severity Index, the Standardized Precipitation Index, which is just precipitation, and then the Standardized Precipitation Evapotranspiration Index, which looks at the difference between precipitation and the evaporative demand. So that takes into account temperature and atmospheric demand as opposed to just precipitation. And then we can also, I think a unique feature of this tool is the ability to look at long-term drought. So we have these drought index timescales that go all the way out to 72 months. So you can look at 3, 4, 5, 6-year drought cycles. For example, the top right here shows the 36-month SPEI ending in October. So that considers the previous 3 years worth of temperature and precipitation data. And you can see that it's still showing up as long-term drought conditions in the southeast part of the state based on these two variables. And another nice thing about the Westwide Drought Tracker is I mentioned it goes all the way back to 1895, so you can go look at maps and time series of the historical events if you wanted to compare them to some more recent drought events. And so I just was showing here the 1934 kind of heat wave and drought that occurred with the temperature and precipitation percentiles, and we had record warm temperatures for the 1895 through 2010 period over much of the region, and record dry over some of that region as well. So a good resource if you're looking at a current drought and want to see how that stacks up against some of the historical drought events. So that tool was based on monthly data, but we really need to look at daily data for a lot of reasons to track these things throughout the year. Updates to the U.S. Drought Monitor is one of those reasons, and kind of more short-term management and planning, you need the daily data. And so this is a great tool put together. I think Dave Pierce mostly put this together from scripts. And what it looks at is it looks at the daily time series of precipitation, the accumulated precipitation, how that stacks up against previous years. On the right, this is for Clark County, and it shows the 5 strongest El Niños, which tend to be wetter. And so this is kind of interesting because a lot of times you see percent of average, and it's for that particular date with reference to the time period leading up to that. So, for example, through November 25th, you'd often see the October 1 through November 25th for all those other dates in the past. But this actually shows you the percent of the average for the whole water year. So this is kind of interesting. That one event for Las Vegas last week brought them up to 23.8% for the entire water year. And then on the bottom, you can see kind of the blue line, I think, is the long-term median, and then you can see the distribution in the spread of wet to dry years. And so again, Clark County is a bit above normal. And then you can get a readout of the record low and record high years for the date. And there are several regions throughout both California and Nevada where you can track these precipitation traces. And lastly, I just wanted to mention the Drought Impact Reporter. We have tons and tons of data to work with in terms of quantitative data to look at how meteorological, hydrologic, agricultural drought is shaping up based on different indices. But what we also really need are these kind of on-the-ground impacts that tell you, what is the result of these meteorologic or hydrologic conditions. And so I want to point everyone to the Drought Impact Reporter, where you can examine impacts throughout the country or your individual state, but you can also submit a report yourself. And we strongly encourage people to go here if they see impacts in their backyard or local forests or local farms, if if you work on farms or ranching, you can submit your own impacts related to droughts here. This is just a sample of what the beginning of the form looks like. You place the marker or put in your address, show exactly where you're located, and there's a series of questions that relate to things like how dry or wet it has been, and what some of those impacts that you're seeing are related to different sectors. And so I highly encourage, if people are seeing local impacts, to go and submit some of these reports. And that was all I had, so thank you. And I don't know if we'll save questions for the end, or if there was anything right now, but thanks.
Thanks, Dan. There's a quick question I think you can answer why I changed presenters. The question is, has the rest of the Mountain West experienced this level of dry conditions this year as well? How much of what we're seeing in California, Nevada is being felt in states like Utah, Wyoming, or Colorado?
Yeah, that's a good question. I think mostly all the maps I showed were just California, Nevada. I guess I can say that much of the West, particularly into Oregon and Washington, have also been quite dry to start the water year. There were some decent storms in October that kind of hit eastern Colorado, but the headwaters of the Colorado River Basin into southwest Colorado have still been quite dry. And so, yeah, I think in general, this dryness has spanned much of the West for the beginning of the water year.
Okay, great. Thanks, Dan. Julia, you want to go ahead?
Yeah, let me see if I can get it into slideshow. There we go. And you're seeing the right slideshow, correct?
Mm-hmm. You're good to go.
Great. Well, thank you. And thank you for having me. So I'll today be talking about the climate outlook. Part of this will be, the first part will be a weather outlook. So I'll be talking about the near term and the storm that's potentially coming, or that is coming this upcoming week, and then the extended range, so week 2. I'll briefly talk about then the SST conditions and what this means, and also the ENSO forecast, and then I'll end on the subseasonal to seasonal timescales. And so what you see up here is just kind of an outline for the talk and what we'll be going through. Before I start, I'll say for each slide, I put a website on the top of where I'm getting the graphics. And so hopefully that helps in terms of knowing where you can find this sort of information. And at the end, I'll briefly summarize, just going through some of the links of where you can find both for short term, the SST and ENSO outlooks, and then the seasonal as well. So for full disclosure, so I am part of CNAP, but I'm also part of the Center for Western Weather and Water Extremes here at Scripps that focuses a lot on atmospheric rivers. And so for that near term, I will be focusing a bit on their tools, because I think there's some neat ways of representing some of the near-term outlooks that could be useful to this group. So let's see. Okay, so here's the short-term forecast, and this is called the Atmospheric River Landfall Tool. And what this uses is the Global Ensemble Forecast System. So it's a NOAA weather forecast that has multiple ensemble members. So it's run multiple different times with different realizations. And so what you're seeing here along in this blue and colorful area is of those ensemble members, so each one of those model runs, how many or what the probability is, so how many of those model runs show an atmospheric river making landfall along the coast. And so here's the latitude along the y-axis, and this is the forecast day along the x-axis. So this was from last night, so it was late on the 24th, and then it goes, you see in Southern California in particular that on the 29th, there's high probability of an atmospheric river making landfall, and similarly later in the week, there's an atmospheric river making landfall in Northern California. What you're seeing on the left-hand side is the number of hours and the probability of it. And so the red is at 90%, the black is at 75%, and the gray is at 50%. And so these is how long, and up here it shows the duration of up to 93 hours of an atmospheric river making landfall. So it gives a sense of how long the precipitation might last over certain areas. So this is what's coming this week. Another way to look at it, because it is probabilistic, I just chose this for Southern California because it was the largest potential impacts of this upcoming storm. And so this is looking at different members, those different model runs. The black line is the average of those different model runs. The green line is, or sorry, the black line is the control of those model runs. The green line is the mean, and then all these little gray lines in between are the different models runs. And so this is showing the potential for how strong. So the height is an indication. IVT stands for integrated water vapor transport. So that includes the amount of water in the atmosphere and the winds transporting it. And so that's often thought of as the strength of a storm or atmospheric river. So you can see how potentially strong it is, and then also the x-axis is time, so the duration of it. And then the gray shading in between gives you a sense of the uncertainty. So how uncertain or how certain is the forecast that this event will make landfall at this specific location? And you can look on the website for different locations to see specifically how it impacts you. The other thing I forgot to say for the landfall tool, there's also an inland landfall tool as well. So you can see about the atmospheric river as it penetrates inland as well. So that's kind of a sense, one way to think about what's coming up in the next week in terms of precipitation and potentially drought amelioration. Another resource that I find incredibly helpful, and Dan mentioned this for the precipitation that fell previously, but also the California Nevada River Forecast Center does precipitation forecast. And so this is the gridded precipitation for this upcoming 6 days from November 24th through November 30th. And so as Dan mentioned, this is where you're seeing quite a bit of precipitation come into the region. So finally getting some rainfall that has been absent over the last, since the start of the water year. Ranging from, an inch to 2 inches in parts of Southern California, Northern California, and finally the west slopes of the Sierras. This storm does seem to miss, or there's very limited precipitation in parts in northern Nevada, but otherwise throughout the region we'll at least hopefully get some precipitation over the next 6 days. Also, the CNRFC does streamflow forecast, and so this is looking, again, I looked at San Diego just because the impacts recently with the previous storm and this next storm are some of the biggest, and so it's the most dramatic to illustrate what the images show. But this is a streamflow forecast for the San Diego River, and over this past week, these blue bars show the amount of precipitation that was received, and then this is the observed streamflow for this gauge. The green is the guidance, and this pink is the monitor. And so this is what's coming up potentially, and here's the precipitation that's forecasted for later in the week. And so the CNRFC has this for multiple locations throughout the region, and you can click on it to see what the recent observations have been and also the forecast. And so for stream flows and potentially flooding, it's extremely useful resource to see what may be coming in terms of river flooding. The other thing that the CNRFC does is they look at freezing level forecast. And so this is, it's a relatively large scale looking at the freezing level forecast, and I just picked a valid date during this upcoming storm, so November 27th at 4 p.m. So this would be Wednesday at 4 p.m. Looking at where the freezing level is. And the freezing level is important because this is an indication of whether the precipitation will fall as rain or as snow. And so there's relatively low freezing levels throughout this time throughout much of California. The freezing levels are a bit higher in Southern California and Nevada, and then even higher in the far Southern California, the far southern parts of our region. The other thing I wanted to mention is that the far eastern part of our region, so Eastern California, Eastern Nevada, is part of the Colorado Basin River Forecast Center. And so they show stream gauge information too for each of the locations. And so here you can see the observed stream flow and then your outlook. And then there's increasingly uncertainty going forward. And this was for a stream gauge, and that was part of the Las Vegas wash. So if you are located in one of those eastern regions of the California Nevada region, the Colorado Basin River Forecast Center has quite a few tools to look at potential flooding and what's coming up in terms of precipitation. The other thing I'll mention in terms of the short-term forecast is at CW3E, there's these map pages that look at watershed forecast. And so what you're seeing here is all the different watersheds throughout California and along the California-Nevada border. And then what you're seeing are these dots are the stream gauges that the California-Nevada River Forecast Center monitors. And so, for example, I just chose the Truckee watershed right here. And then what this is showing the precipitation over in 6-hour time chunks. And so you get a sense of, 3-hour over the watershed. And so you get a sense of what the rain rate may be throughout the storm. And then it also takes an average over the basin and estimates what the potential accumulation of precipitation will be in terms of both acre feet, which you see down here. And so this is just a way to help think about water resources, about what might be coming in over the watershed, and also the potential rain rates that could be hazardous or beneficial. The last tool that I'll point out in this week, kind of one short-term weather forecast, this is a freezing level tool that is part of the maps. And so again, it was for the Truckee watershed, and then this uses the Global Forecast Ensemble model that I mentioned earlier. And so it's a whole bunch of different models run about weather forecast, and it's looking at freezing level. And so this dashed line that you're seeing here is the mean of the freezing level from November 22nd through November 28th. And the red dots are one of the model runs that are warmer than this mean, and the blue dots are cooler than this mean. And so what it's able to show you is what that freezing level may be. And then down at the bottom, it's showing how much of the watershed will be all rain, or half snow, or all snow. And in this event that we looked at the freezing level from the California Nevada River Forecast Center, there were pretty low freezing levels. And so because of that, for the Truckee, this event that's coming up, most of it will be as snow. And so this is just another way of looking at whether or not that precipitation is coming down as rain or snow and what that may mean. So still on the weather timescale, but that extended range weather timescale, so week 2. So this is looking out, 7 to 14 days here. It's even showing 16. This is the same tool that I showed before, but it's extending out farther into the first week of December. So the colors are still the probability. So looking at all those different model runs, what percentage of them or how many of them show a potential atmospheric river. And you can see that there is this potential for some additional atmospheric rivers later into next week. I just should say the uncertainty increases quite substantially once you get out into week 2, but it just gives you a sense of what might be coming. Another tool to look at the extended range forecast is from the Climate Prediction Center, so CPC, which is part of NOAA. So this is the 8 to 14 day precipitation forecast, and this is just showing the probability of above normal versus below. And so this is valid for December 2nd through December 8th. And so it's showing that for much of the region, there's a 50% probability above being the normal precipitation for this time of year. And then you can also look at this in a temperature mode from the Climate Prediction Office. And so temperature-wise, for much of Southern California, Nevada, even Central, it's most likely about normal, whereas the northern regions have a probability of being a bit cooler in that 8 to 14 day range. And it's represented this way instead of actual temperatures just because in this time frame, the scale of the forecast does drop substantially, but it just provides a sense of whether it will be warmer or colder. So now I'm going to shift gears a bit to look at ocean temperatures, because this can have implications on some of the climate we do get. And so this is, again, another NOAA product, and this is looking at surface ocean or sea surface temperature anomalies for the Pacific Basin. And what you're seeing here is that through much of the Pacific Basin, or at least the eastern North Pacific, is substantially warmer than average. There was in September and October and even early November a very warm area. Some people were calling it Blob 2.0 because back in the 2014 drought, there was this really warm area of sea surface temperatures. That warmth is still there, which you can see off the coast of Canada and Alaska here, but it has dissipated compared to the strength or how high those anomalies were earlier in the fall. And then I feel like no outlook would be complete without looking at the ENSO status and projections for this upcoming year. And so this is again provided by the Climate Prediction Office. They do an update, I think it's every 2 weeks, about the ENSO status. This is where you can find a lot of this information. They have a presentation that goes into quite a bit of detail. They also have some higher level explanations of what currently is going on. This is just looking at the probabilistic forecast for ENSO. The blue is La Niñas, the red is El Nino forecast probability, and the gray are for neutral. And what you can see starting from October, November, and December, and here along the side you have probability as well that ENSO neutral is favored throughout the remainder of the year, and so it won't be either El Nino or La Nina most likely this year, and we'll stay in a neutral phase between that neutral ENSO phase. So now I'm going to switch to more of the extended range forecast, but I'm going to start with something that's actually not a forecast, but just it provides an interesting sense of how to think about where we are in the year and what this may mean for total precipitation. So this is the odds of reaching normal precipitation. It is something that Mike Dettinger has developed, and with collaboration with CW3 is updated monthly. So this was as of November 4th or November 1st. The downside of doing a webinar at the end of the month, a lot of this will be updated with the recent storms as of December 1st. So this may look quite different especially in the southern region of what this looks like, but this is the odds of reaching normal precipitation. And so as Dan mentioned, because November was so dry, even though it's generally a dry month, but it was very dry compared to October and November were very dry compared to what is typical. You see the odds of reaching normal are in the 30%. So 30% chances of reaching normal for much of the state. Some of the northern regions, it's a bit higher. The one thing I will point out is that our precipitation isn't normally distributed. So even at the very start of the water year, so this is as of October 1st, many of the odds are below 50% to start off with. And so this will be updated, like I said, at the beginning of next week, once November is finished. Within the website there, you can look at different odds of reaching 50% of normal, 75%, and so forth. And so you just get a sense of what this year may look like based on what we've gotten this far and historically what we've gotten in those later months. And then this is the drought outlook for the region. Again, here, this is from the Climate Prediction Center. And so it's showing that drought will persist throughout much of the Southwest. And this was valid for November. And so this is a 1 month outlook. The other thing that is relatively new, and Dan did a great job of describing the EDDI, their new EDDI forecast. And so this was based on an October, the models were initialized in October, and this is what EDDI will be like coming up in the future months. And so the November and December are mid-range, except in these parts of northern Nevada where it's projected or forecasted to be, there's less atmospheric thirst, whereas then later into the winter and into spring, there's forecast of more atmospheric thirst going forward. And so moving on to the subseasonal, so this is looking at 1 month. This is from the Climate Prediction Office as well. This is temperature, and so A means above normal. Some of EC is equal chances of above or below normal. I mean, we don't see anything below normal, so this is the chances of temperature in California and Nevada being above normal, which is 50 to 60%. And so this was made the 21st of November and it's valid for December. So it takes in some of that information about the near-term forecast, but it makes a 1 month seasonal forecast. And then this is what it looks like for precipitation. Similarly, the A is above normal, EC is equal chances of below or above normal precipitation. And then likewise, it was made on November 21st, and it's valid for December 2019. And so this is actually what it's showing, that for December, this 1 month lead time, California has about equal chances of being above or below, whereas Nevada, it's forecasting that it will be a bit wetter, about 40%. It has a 40% probability of being wetter than normal. And then this is also a new seasonal outlook for 3 months. I don't want to stress this a lot because the scale of these 3 months forecasts are generally pretty poor. And so this is what the forecast is showing, and I think it's good to show, but know that there isn't a lot of skill with these forecasts. And so this is again, it was made on the 21st of November, and so it's valid for December, January, and February. And this is looking at temperature. And so for much of our region, there's a 60% chance of it being above normal temperatures. And then in the very northern tips of the region, just a little bit less being above normal temperatures. For precipitation, for California, there's anywhere between 60 to 50% chance of being below normal precipitation, whereas Northern California and much of Nevada have equal chances. So it's a 50-50 of being above or below. And this is the website where you can get these new experimental seasonal outlooks from the Climate Prediction Office. So just to summarize, in the near term, there's this Thanksgiving storm coming up, which is about 1 to 3 inches in California, about 0 to 2 inches in different parts of Nevada, generally low freezing levels. In the extended range, so that first week of December, week 2, there's potential for more storms, though it remains pretty uncertain. It's most likely this year will remain in an ENSO neutral. There's additional sea surface temperature warmth in the Northeast Pacific, though it's not as strong as it was earlier this fall. And then just using the amount of precipitation that we've gotten thus far and the historical record, the odds of reaching normal precipitation for the year as of November 1st is about 40% or lower for certain parts. And the long-term forecast is warmer and drier, though, as I said, these forecasts do have pretty limited skill. And so this isn't, I didn't show and click through as nicely as Dan for all the different resources because I showed them along the way. But in terms of week 1, this is what the images that I showed from the CNRFC and CW3E website. The extended range was from CW3E and the Climate Prediction Office. So the Climate Prediction Office goes from week 2 to up to 3 months. Dan touched on this, but the Great Basin dashboard, the forecast page, is actually extremely helpful because it pulls together a lot of the products from NOAA in terms of anywhere from week 2 out to the 3 months. And so if you don't know where something is, if you just remember to go to the Great Basin dashboard, it can take you there. And then also I'll leave with this ENSO and sea surface temperature information from CPC and NOAA. And so this is the link if you want to get to that website. So I will wrap up there, and I'm happy to take any questions, or I can also go to any specific websites if people are interested. So thank you.
Great, thanks, Julie. At this time, I would say thanks, Dan, for your great presentations. At this moment, there are a couple questions I can pop for you, Julie, in a minute, but I'll give folks a couple minutes to enter their questions. While I remind folks that the recording from this webinar will be available on the drought.gov page and the drought.gov YouTube in the coming probably 24, 48 hours. Our next webinar is scheduled for Monday, January 27th, and soon that information and registration information will be available on drought.gov and will also be sent out in the post webinar email. So Julie, the questions we have, I think someone is asking, the 1 month term outlook doesn't seem to jive with the 2-week outlook you showed December 2nd to 8th. Do you want to talk, I think they're hitting on the differences between the CPC forecast and the AR forecast. You want to explain maybe why they don't quite jibe?
Yeah, and I think this is what will happen. So from my understanding, the CPC forecast is not updated as frequently as the AR forecast. And so I think the 1 month forecast just hasn't taken into account the recent storms that have been developing potentially in the global forecast system in the GFS. And so because of that, you're not seeing the same 1 month. And also you have to remember that this is for 1 month, the storm that could potentially be coming. December is a big month for California and Nevada. It's one of the big 3. And so even if we're getting some precipitation, it may not be above normal too. And so I think those are the 2 possibilities of why they're not jiving as well. Of the amount of precipitation that is forecasted in that extended range actually isn't that much more than above normal, or the likelihood of equal chances. And that the fact that we do often get so much of our precipitation in December, if we don't get something later in December as well, it won't push us above normal.
This is another question per the odds of reaching normal precip map. Was there a map that was produced last year at this time?
Yeah, so actually if you go to the website, I'm gonna try and do that. You can, let's see. So here's the IVT product. So this is the CW3 website. And if you go to forecast, you see this odds of water year precipitation.
Julie, we still see your PowerPoint.
Oh, give me a second, sorry.
There you go.
Now are you seeing it? Okay, I was on the wrong screen, I apologize. So this is the CW3 website, and just to find it, if you go to forecast and odds of normal water year precipitation, there's a drop-down bar. Oh, you can change your water year here, so you can go to 2019, and then there's a drop-down bar that you can look at the different months that this is updated. So you can go back in time too to look at the odds of reaching normal.
Great. And then this is a more general question for both of you. The person was commenting lots of good resources already mentioned, but any other tips on how to stay updated?
So to be fair, I often will just go to the Great Basin dashboard to get a synopsis of kind of where we are in the water year. I actually think that is a really good resource of the West, and you can look at things pretty quickly. So that is one of my go-tos. And then if I find something interesting, dig into it more. So I would say that I think that's a really good resource kind of climate, what's going on generally throughout the West. It depends on kind of what time scales thinking about. In the short term, like I said, the 2 that I really look to is the CNRFC, and I, partially because I'm at CW3E, I go to that website a lot too. Yeah, and I know you may have others too.
No, I think that was a pretty good summary. I was just also going to add your local National Weather Service forecast office. They often in their local discussions have a lot of good information related to current drought and potential ongoing drought or flooding or more weather-related issues. But those are good resources.
All right, thanks guys. Since we are at the top of the hour, there were a few more questions specific to tools. I can either follow up with you guys after the webinar, or all the tool links will be included into the post-webinar, like the email, the 2-pager, etc. So if those folks want to dig into the tools, they can dig into them there. I think as a clarification of colors, etc. So I recommend checking out the tools for those last few questions I'm not able to get to right now. With that, again, I will say thank you everyone for joining us. We hope you found this webinar informative. Please contact myself or either of the speakers if you have more questions about the tools, want to be more involved in the California Drought Early Warning System, the webinar series, etc. And please fill out our post-webinar survey. We really do read those responses and they help us figure out which topics are most timely and what you guys are interested in seeing. So otherwise, thank you everyone, and have a good Thanksgiving week.